Hi, this is Stephen Brower from Irvine Valley Community College. This is for CSIT 256, Computer Architecture and Assembly Language. And this is part 3 of Irvine Chapter 3. And in this part, I'm going to try to work on declaring variables. Within the template, there is, I'll have to talk about this on another video. But the .data that's here, that's a compiler directive. The .code that's here, that's a compiler directive. And behind the scenes, the data will go into the data segment, the code will go into the code segment, and we're doing what's known as segmented programming. When you look at the underlying memory for a program, the operating system will treat the data and the code differently. Mainly because code doesn't change, data does. Now, we have the ability to change the code, but we generally don't. So in the template, I do have the thing that says insert variables here, flush left. So the general format, and this was in the overview, but the general format for variables is the variable name, data type, initial value, and then optionally additional values, which I'll get to in a little bit. So the demo that was done for Stallings Chapter 3 showed the declaration of apples sold. So apples sold, SD word, and I believe it had that as 8. Okay, and so this is, we'll hold the number. Apples sold. And that 8, by the way, is a constant. But in this line that I just typed, the initial value is 8. What I do is I want to jump to the total sold. Now here, that means uninitialized. I probably should pause the video when I'll fix that later. Uninitialized. So the question mark is what we use to not give an initial value. And so comparing it to, like, if I compare those 2 lines above to Java, right? If I compare those 2 lines above to Java, it would have been int apple sold equals 8 and int total sold. So in Java, well, int is a 32-bit signed number. So the SD word is here. Now for the data types, and I'll list those out again in a moment, the first letter, if the first letter is an S, it's signed. So SD word, well, D word is a double word, so it's twice what a word is. A word is 16 bits, so 2 times 16 is 32. It's a 32-bit variable, the S being that it's signed. The int that we had in Java corresponds to an SD word in terms of assembly, and the ranges on those are the same as it would be for the int in Java. Okay, so in terms of guidelines, and I'm jumping around a little bit, but in terms of guidelines, name the variables the way you would if you were in Java with Brower as the instructor. I like meaningful variable names. I like to have the mixed case, starting with a small letter, subsequent words capitalized. That's why apple sold, capital S, total sold, capital S. And so my guideline, or my programming guideline, is that you use camel case for those. In terms of the rules for identifiers, there's a slide in the Irvine Chapter 3 that does list, the total number of characters that they can be, cannot begin with a number, and which symbols are allowed as part of it. What I would just say is treat the variable like you would a variable name in Java. And so if you do it that way, starting with a letter, meaningful description, camel case in terms of subsequent words capitalized, you'll be fine for me for this course. Hang on a second. I just want to. Sorry, I was checking my notes. So what the Irvine Chapter 3 also gets into is a whole slew of data types. The byte is an unsigned 8-bit variable. And actually, the Irvine Chapter 1 slides had a slide that gave for the unsigned numbers the ranges of values. So for a byte, the smallest number is 0, and the largest is 255. So with an unsigned 8-bit variable, those are the ranges. And again, there's a slide from Irvine Chapter 1 that does have the ranges. S byte is a signed 8-bit variable. The smallest is -128, and the largest is 127. And again, in Irvine Chapter 1, there are there's a separate slide with the signed values. Now, you might be saying, well, why would we choose to use a byte? Well, one thing is we may have no choice. And what I mean is, suppose we're sending something to the operating system. There are some cases where the operating system only wants a byte. So we have to declare a variable as a byte because that's what the operating system wants. If we're dealing with a peripheral, maybe the configuration operator is only a byte. And so we have to make sure that we're dealing with a byte and nothing gets larger than it for sending that byte off. So sometimes it's more a requirement. The other thing is, depending on what we're holding, it's a way of saving memory. Now, I know nowadays we're not as concerned because we can have gobs and gobs of memory, but generally when you're writing assembly, you're writing in a device where there isn't that much memory, and you want to preserve your memory use as much as possible. So you don't want to be wasting bytes. You don't want to be using a D word, which is 32 bits, if you can get by with 8 bits. Okay, now word is an unsigned 16-bit variable, and I'll just refer you again to Irvine Chapter 1 has the ranges. And S word, by the way, I was teaching this course for several years until finally students said, "What's sword?" And I never put that together before, and now all it's stuck in my head. I keep saying sword, but it's S word, and that's a signed 16-bit variable. And then, which we did mention before, so D word is an unsigned 32-bit variable, which would be 0 to 4 billion. 32-bit variable. And SD word, be consistent, is a signed 32-bit variable. same as int in Java. Okay, so the chapter does point out a couple other, it does point out a couple other types. When we get to chapter 12, which is the floating point, we'll be dealing with those at that point. So all of these variables that I just created, these are all integer variables. And that's a key thing. They only hold whole numbers. And then the registers only hold whole numbers. So EAX, EBX, ECX, EDX can only hold whole numbers. If we have a floating point number like 3.2, we cannot move that into our 32-bit registers. We actually have to use a floating point register for that. We'll get to that in chapter 12. That does mean between now and chapter 12, we're only going to deal with whole numbers. So we're not going to actually get to dealing with prices until we get to chapter 12. Oh, right. Okay. So I did mention up here additional values. And you say, well, what is that? So remember doing in Java. Okay, I'll do this as another side. So remember doing in Java something like int days in month equals, so January, February, let's ignore leap year, March, April, May, June, July, August, September, October, November, December. So remember doing something like that in Java, where we actually would have an array that we would embed in the code, and we would generally use it for things where the values aren't going to change. Let's not talk about leap year. I don't want to go there. But that would be an array that we could create in terms of Java that would have the days in the month. Well, in assembly, to do the same thing, so days in month. Now, in terms of the data type, a byte is sufficient. Byte. And then in terms of the values, well, instead of me typing it because I'm too damn lazy, that's an array. So if we give multiple values when we're declaring a variable, we're actually declaring an array. So days in month, in terms of this assembly program, days in month is an array of bytes that has those values, those 12 values, unless I missed a month, has those 12 values in there. But that is an array. Okay, so this is array of 12 bytes. Okay. What I will do, not now, because we're at 13 minutes on this video, what I will do in another video is I will display, I will load into EAX one at a time by marching down that array. So I will have a demo on that, one of the separate demos. Well, I'll go and use that. But what I'm getting at, is this part here that says additional values. That's what this means. These are all the additional values that are being used for days and month. So it's how an array, and when I mean by an array, it would be more like the array initialization that we would have in Java. It would be more like that. And yeah, okay. Let me pause for one more second. I'm probably not going to be able to do this right. Oh, I know. Let me pause. What I wanted to do is just do one more thing that like Java has. So in Java, suppose we declared this apples sold by month as an array of 12 integers, and we just did it this way. Java will initialize all those values to 0. The dupe command that we have in assembly, we precede with a number, and in parentheses we put the value. So this would give us apples sold by month as an array of 12 zeros.